In this application, we're going to look at using the CCS Prima white light confocal single point sensor to go ahead and measure the thickness of a clear material. And just real quickly, this is the model here with the fiber optic and the passive probe. And what this does is we start off with a LED white light source. We go through a lensing arrangement, and it creates a monochromatic measurement span, and as that hits a target, it bounces back up into the beam splitter, goes through a filtering aperture, or basically a small pinhole, and we have a white light spectrometer here, and so it is measuring the color very accurately in the nanometers in the wavelength, and then of course we have that calibrated, the displacement positioned as a function of color. And so with this sort of technology, we can measure almost any surface, and on clear and transparent surfaces, we can measure through them and see both surfaces and calculate the thickness using that, and we can plug in the index of refraction of that part. So in this application, we've used the CL2 probe, which has a range of about 0.4 millimeters, a standoff of 11 millimeters, and we're going to have a resolution of 22 nanometers and a linearity of plus or minus 80 nanometers, and we should be able to measure on a real specular surface plus or minus 28 degrees and a larger slope on diffuse surfaces. So and we're using the MG140 magnifier on it, so it gives us a 3.4 micron diameter spot, and we should be able to see a minimum thickness measurement of 14 microns. So as long as it's typically 14 microns or larger, we should be able to differentiate between the two surfaces and make a thickness measurement. So here's the actual first surface that we measured. We measured a 1 millimeter by 1 millimeter section, and every 1.5 microns we took a data point, and then we would drop it down 1.5 microns and scan again. So here we've taken over 400,000 single points in about 30 minutes just to give a lot of data to sort of make sure that we're seeing everything we're supposed to see. So this is the 2D map of it, and if we come in here and we look at a profile, and let's just start scanning through here, and you can see we are showing approximately between 4 and 8 microns of thickness going from west to east. Once again, this is showing the actual thickness as we're scanning across it. It gives you a good idea of there is quite a bit of variation, and appears to be some spots where we have very thin areas. If we go to north to south, it appears to be a little bit better. And here you can see this just shows that we had one speckle that went out of range, and so it's just showing that straight across, and that's probably the data point right there. So this is, as you can see, a really accurate way for us to be measuring the thickness of this total surface, this 1 millimeter squared surface, looking at that. And let's just come in here and do a scale going to absolute. So you can see that we're measuring it from 207 down to 202 microns absolute, and we're seeing probably about 8 microns of that variation.